tema Tecnologia e modernização da construção civil. Chamaremos ele engenheiro civil e mestre em engenharia estrutural, tem mais de 30 anos de experiência em projetos, construção e análise de materiais de construção, é diretor de engenharia da Framecad, América, e antes da Framecad, foi diretor do Centro de Pesquisa da Associação Nacional de Construtores nos Estados Unidos. Gerenciou projetos de pesquisa, teste e desenvolvimento para a construção de métodos e materiais e tecnologias emergentes. Nader é ativo na elaboração de normas, códigos e especificações de engenharia para a indústria da construção. Autor e coautor de várias publicações sobre habitações e acessibilidade econômica, atua em vários comitês e associações nacionais e internacionais de código e indústria. Chamamos ao palco Nader Hajj e com ele Branly Rodrigues, gerente regional para a América Latina e Caribe da Framecad, empresa líder em tecnologia no mundo no setor de produção de aço conformado a frio, com presença em mais de 120 países, engenheiro civil especializado em aço e MBA executivo para a Escola de Organização Industrial da Espanha. Trabalha há 15 anos com projetos e execução de obras residenciais, comerciais e para o setor hospitalar, e há mais de 10 anos com Light Steel Frame em pesquisa e desenvolvimento neste setor. Por favor.
Good afternoon, everyone. I'm sorry, I wish I know Portuguese, but you have to settle for English this afternoon. My name is Nader Hajj, and I work with Branly. We work for a company in the US, New Zealand company actually. It's called Framecad, and we're a technology solution provider. And I'm going to show you a little bit about what we do, and we'll talk a little bit about the industry in general, since we only have 20 minutes or so it's very difficult to cover everything in 20 minutes, but I'll try my best. Again, thanks for inviting us. First of all, I want to thank the people who are in charge of this Congress. It's always nice to be back in Brazil. I've been here a few times in the past, and I always enjoy being here. The food is amazing. All right, since we're going to be talking about building materials and technological advances in building materials and construction, I figured I'll take you back 9,000 years and go all the way to the current time. So 9,000 years ago, everyone was using brick, adobe, earth products, because that's what was available. And then people moved on from brick and adobe to timber, from timber to granite, limestone to marble, to old concrete, especially in Rome and the Greek Empire. And then glass was discovered around the year 100 AD. And from that, they went into cast iron. However, the use of iron was not like what we understand it today. It wasn't steel. So from iron the technology improved in about the Middle Ages in 1700s and so, and they built the first bridge out of steel in Europe. After that, engineered lumber came into the picture in the year 1852, and then, of course, the Eiffel Tower in the late 1800s, asbestos and then the Eiffel Tower, and then PVC, reinforced concrete, and finally, cold-formed steel. So you see cold-formed steel here, or light steel framing, although it became widely used in the 1990s, it was actually developed and invented in the 1940s. After the Second World War, there was a huge demand for houses, whether it's in the US, in Australia, New Zealand, South Africa, from the soldiers who are coming back from the war, and they didn't have any houses. That's one reason. The second reason, there was an excess capacity of steel because they didn't have to build tanks and airplanes anymore. So in order to keep the factories open, they looked at houses to build them out of steel framing. It didn't succeed very well because the technology wasn't there. It was old, labor-intensive, engineering and standards weren't developed. So there were too many obstacles to do that. So we're stuck with the traditional methods. Traditional methods, if you look at this throughout the world, it's either concrete, timber, or whatever you can come up with from the nature. Low income, we call it low income housing, affordable housing, whatever you want to call it. That's what's being built throughout the world. And that's a problem because we have earthquakes, we have cyclones, hurricanes, termites, fires, you name it, a lot of natural disaster, and each one of these traditional methods or traditional materials is prone to some kind of damage. Earthquakes, for example, and I'm not sure if Brazil is in a high seismic region, but most of South America is. If we look at Chile, look at Argentina, look at Colombia, most of them are in high seismic regions. And we build a lot of concrete buildings, and actually concrete, earthquakes do not kill people, concrete kills people. So if you have a 4 or 5 story building, collapses in a seismic event or an earthquake event, a lot of people die because of the weight of concrete. So what do? We don't have enough houses in the world, and we can't build them fast enough using the traditional methods. So if we look at the technological advances in the construction market, and this is actually, it's a very popular report that was done by the McKinsey Group in the US. If you look at manufacturing, let me see if I could do this right. Anyway, it's not. If we look at manufacturing from the 1995 to roughly about a few years ago, we see that the curve is going up. We look at the economy is going up, but if we look at construction, it's the same way. So we've been building the same exact method for the past, I don't know how many years. We have not improved, we have not introduced technology at the same rate as other industries have introduced their technology into their market. And like I said, you look at it, whether it's concrete, timber, wood, plastic, PVC, it's been pretty much the same. Technology, we have a lot of technology there that can be and should be used in the construction market, but we haven't been using it. So what we did is cold form steel or light steel framing comes to the rescue, of course. The basic concept for light steel framing is the stud, the C-stud, the channel. That also hasn't changed since the 1940s. That was what the industry decided on about 50, 60 years ago, and that's what we're still doing today. It's easy, it's engineered. Engineers love that because they can calculate the structural characteristics or the capacities and the strength of the member, and architects can draw it easily. So everyone likes that. The beauty of light steel framing or cold form steel framing is it can be integrated with any of the traditional construction methods or materials. So it doesn't have to be used by itself as a standalone product. You can use it as a standalone product, of course, but if you don't have to, you don't need to. You use it where it makes the most sense. So if I design a building and it's more economical and better designed to design it with concrete or with timber or with hot roll steel or precast, there's no problem at all. Cold form steel can be accommodated and can accommodate all other construction materials and techniques and methods. So what did Framecad has to do with all of this? What Framecad took the old technology, which is roll forming, manual, hand work, it takes a lot of labor, and automated the system. They automated and integrated the engineering and detailing software with the roll forming machines and the manufacturing of the product. That ended up in a lower cost, faster, affordable, economical, sustainable, and energy efficient product. And that's what the gentleman before me and the gentleman before him, they were talking in the panel, they were talking about sustainability, and they were talking about energy efficiency and all of that. That's what we bring to our clients and to our users. Again, you want something marketable, affordable, economical, energy efficient, and sustainable. So how do we do that? We could look at the offering that Framecad does from engineering, detailing, to software training, BIM integration, if you are into the BIM integration, shop drawings, manufacturing, which is using the Framecad machines, roll forming machines, factory site assembly training, building material selection, erection training, finishes, support services, and so forth. So we put all of that under one umbrella that we can provide it. It's a one-stop shop. You don't have to go and shop around somewhere else and try to collect all the information. We already have that. We already have that for you, and we could either deliver that to you or train you on how to use it, how to select it, where to buy your steel from, where to get your fasteners from, and so forth. So that's what Framecad is all about. It's about automation, integration, providing a technological solution for your building construction company or framing or contracting or whatever you do. So if I look at the Framecad process, you could look here. It starts out on the top left-hand corner with a picture, a drawing, something you sketch on a napkin or on the back of an envelope, and you take it into a model. You run it into the software, the Framecad design software. It does the full engineering analysis. It provides the reports, engineering reports for your municipality and jurisdictions so that you can get the permit. And then it goes to the roll forming machine, everything that I've said so far, it's done automatically. There's no manual labor in it. So the software sends it to the machine. The machine is a roll forming machine, is automated. The machine produces it. You assemble it and erect it, and the finished product is at the end. So that's a cycle or the process of what Framecad system does. So in general, though, okay, you have all of that. Let's put it in pictures. Let's put it a little bit more, instead of this circle here, let's put it a little bit more into pictures and show you the process. Steel. The gentleman before me here showed you how steel gets made with iron and carbon. And of course, nowadays, in reality, we cannot make steel only but with iron and carbon. We have to have recycled steel. Most of the steel mills in the world, they have to have recycled steel enabled to make good new steel. And actually, the more recycled steel you use in your steel, the more LEED certifications and LEED points and green points, green building guidelines, and I don't know which program you have here in Brazil. In the US, we have LEED certification, LEED, and we have green building certification. So the more recycled material you use, the more points you get, and the more green your system is. Anyway, the coils get produced by the steel mill, and these are large 25 tons, 30 ton steel coils. And then they get slitted to the proper width that you need for your machines, whether it's 150 millimeter, 180 millimeter, depending on the profile that you are producing. Every machine gives you the specs of the profile, the width of the profile, the width of the slit, actually, or the width of the steel coil that you need for your machine to run it. And then, like I said earlier, you start with a drawing. Whether it's a CAD drawing, a rivet drawing, a vertex drawing, whatever it is. You start with that drawing, you run it through an engineering software that we call Structure. It's a DWG file, which is IntelliCAD or AutoCAD-based drawing. And then the model provides you a 3D model of whatever you input, and it does the full engineering, the full calculations, full analysis. And then it sends it to a detailing, let's call it shop drawing software, that's called Detailer. So Detailer, what it does, it gives you a 3D view of the product, whatever it is, a building, a house, panel, walls, truss, anything you do, and it translates that into a machine language. So it does that automatically. It takes whatever you designed, puts it in this software, translates it into the machine language, and then it fed into the machine, and these are some of the machines that we offer. So the file gets fed into the machine, and the machine produces the profiles. As you can see here, few shots of the machine producing the profile. The profiles are produced, cut to length, exactly as they were designed, with dimples, holes, notches, labeled, chamfer, swaged, etc. So you don't do anything manual. Everything is labeled. It's like a Lego set, so you just put it together. All what you need is put it together, assemble it, whether it's in the factory or on the job site, and put the screw it together. Put the fasteners in the hole, if you can see in the bottom right-hand side picture, you just line them up and put the screws in. Then what you do is you stack the panels, and if you're doing this in the factory, and you ship them to the job site. We have several clients, they take the machine to the job site. So you have both options. The machines are mobile, so you can either do it in the factory or move the machine to the job site and fabricate everything there so you don't have the transportation. While you're doing this, your other laborers or other subcontractors, they could be doing the foundations. And one of the benefits of light steel framing or cold form steel framing is it's light. So if you're building, let's say you're building a house, a typical house is about probably 60, 70 tons of concrete if you're building it with concrete. A typical house with light steel framing, it's probably about 10 tons. So you could save a lot of money in the concrete, in the actual foundations, especially in areas where you have bad soil. You could really save a lot of money in the concrete. Or in areas where you can't get the concrete to that area, you don't have to transport as much. Once you do the concrete, the foundations, then you do the erection. So the panels arrive on site, and then you just stand up the panels and connect them together and fasten them or anchor them down to the foundations or the concrete. That's a shot of a school that is built, and it shows you the walls have already been erected, and the trusses are down on the floor waiting to be installed on top of the walls. After you do that, you do your MEPs, mechanical, electrical, and plumbing, and other services. One of the big advantages of light steel framing is you have the cavity, so you don't have to drill, cut, or break sections of the blocks or the concrete. You can run your mechanical, electrical, and plumbing wires and waste pipes through the holes in the studs or through the penetrations or the triangular shapes of the trusses and the joists. You apply after that your floor sheathing, and it could be cement board, it could be plywood, OSB, it could be corrugated sheet metal deck with concrete, it could be with lightweight concrete, it could be Hebels, could be precast. You could use anything. Anything that you want to use, you can use it. Most people rely on, since this is a dry construction method, they put either cement board or plywood, some kind of wooden products. Your insulation is installed in the cavity, depending on the climate you're in, whether you need 12 millimeter of insulation, 20 millimeter, 25, or if you don't need any insulation at all. Your building code dictates the level of insulation that is required for a steel-framed wall or steel-framed building. And there's a lot of available publications that give you the effective R value or U value for a steel-framed wall or floor or truss, in case you're interested in that. There's a lot of available information on that. Your interior finishes, whether it's gypsum board or cement board or magnesium board, whatever board you want to use. Most of the people who use light steel framing or cold form steel framing, they use gypsum board. Exterior cladding, again, there's no different than traditional building methods or materials. You can use cement board, you could use EFIS, exterior insulated finishing system. You could use stucco, you could use brick, you could use stone, block, you name it. And it can be used with cold form steel framing. And there are already available details that shows you pretty much step by step on how to install or how to attach these finishes to the steel framed structure. Another shot, it shows you a low-rise and a mid-rise building. So there is no restraint or restrictions to how many levels you can go with cold form steel framing. The most that has been done in the world, actually, is roughly about 12 levels with cold form steel framing. And it's not because it's limitation on the material. No, it's limitation on the economical use of the material. So after 12 levels, it's not, right now, it's not very economical to use light gauge steel or cold form steel. And by the way, we use cold form steel, light gauge steel, light steel framing interchangeably, and the proper name of it is cold formed steel. That's the technical name, and that's the name that is in several of the building codes and standards around the world. So there has been a lot of mid-rise building, and when I say mid-rise, anywhere between 4 to 8 story buildings built with cold form steel framing throughout the world, not only in the US only, but throughout the world. Roofing, same thing, whether it's a flat roof or pitched roof, you could use metal roofs, you could use clay tiles, metal tiles, shingles, asphalt shingles. It depends on your market, it depends on what's available and what's marketable in your region. This is a finished house actually, and you could see the architectural and the combination of the timber finish and the stucco finish. This one is in Atlanta, in Georgia. It's a big house, and it's all used, everything in this house is cold form steel framing, from the floors to the walls, to the ceilings, to the roofs, and everything. I'm almost done. So why Framecad? Like I said, we initially, we automated the system. We went from the traditional method, which is label, measure, cut, drill, fasten, assemble, etc., and we consolidated that into 2 tasks, which is fasten and assemble. Standards-wise, the most popular standard in the world is the North American spec, which covers the United States, Mexico, and Canada. And the US, or the North American, I keep calling US, but it's the North American actually, it has a lot of sub standards depending on which product or what market you're in, whether it's trusses or whether it's wall panels, lateral floors, etc., etc. So instead of learning the entire spec, you could use one of the smaller specs and use them. The US building code, it's the International Building Code, references the spec, the North American spec in the building code like any other building material, so it's codified, so you don't have to go and reinvent the wheel. Typically, building code adoption, it's simple. It's extremely simple. It's either listed in the building code and is deemed to comply, or you could have testing, whether it's university or accredited testing facility. They could do the testing and the evaluation, the assessment, or it could be an engineering company as well, and produce a report, an evaluation report for you to certify that the product that you are using is certified and can be used in the building you're building. That's assuming it's not, the light gauge steel or light steel framing is not in the building code. Thank you so very much, and I'm not sure if we're taking questions, but I'll be around. Yes. Let me introduce that. Yes.
Thank you. In addition to this, I would like to announce that tomorrow morning at 9 a.m., we're going to be having a workshop called Framecad Through Experience. Basically, we're going to be building with the steel and actually have the real experience dealing with light gauge steel and framing. We're going to be doing, since it's a very selective and space restrictions, we're going to be basically sorting, the amount of seat on that. You can see me at our stand at the general lobby to actually get more information. Thank you.